Okay, everybody, this is Mr. Ainsworth. Good morning, good evening, whatever time it is. All right, we are going to get into a review on Unit 1 in Algebra here, which covers solving equations, solving inequalities, working with literal equations, working with dimensional analysis and unit conversion. It involves many different concepts here with a lot of arithmetic skills. So get out your notes, use them if you need to. This right here, conversions, are in section 1-12. All right. So if you don't have this in front of you, take out your notes in section 1-12. The conversions are in there. I will give this to you on the test. All right. And remember a couple things. This right here, this video is not only to help you, but I'm going to give extra credit for anyone who goes through this video and takes good notes through it. And I want you to do all your work in your spiral. Okay. Do all your work in your spiral. And if you show this to me, I will give you. I don't know. I'm going to reward you big time in your homework, because not only will it benefit you to help you get ready for the test, but because you're a go-getter, I'm going to reward you and give you some extra credit points uh, towards your homework scores. Okay, so EC is in your homework category. Okay, not your test category, but your homework category. All right, and you see, our last homework assignment was 36 points, right? I'm going to make this a 10-point extra credit assignment, which is huge in respect to. Now I'll make it 12. It's worth three different. It's like worth of three homework assignments total. All right, so plus 12 EC. If you do this and show it to me and do a good job in your spiral, I'll reward you. So not only will it help you with your grade, but it will also help you be able to do really well in your test, because the tests are worth 55% of your grade. All right, 55% of your grade total, and that is huge. All right, so a couple things you're going to need. You're going to need your notes. Open up a section 12. You're going to need your calculator here, because you have to actually do this with me. So have your calculator out. You can't just take notes, okay, because that's not how you get good. You got to be interactive. Okay, so you have to interact with the video. Interact. You're going to need a calculator. Okay, your notes. Okay, and all your resources. All right, so do it in your spiral, interact with me, and remember, this is a video, right? So I want to see you pause when you need to, play when you're ready, all right, and take good notes, because I will not, okay, give you extra credit if you don't take good notes. So listen to me through the video, do a really good job, show me uh, on test day, which is Thursday and Friday, by the way, of this week, that you went through this video on Wednesday night, because that's the night that you can do it here. Not Thursday night, but Wednesday night, because I'm telling you guys about this on Wednesday, so the only night you have is Wednesday night. And go for it, okay? It will help you out tremendously, trust me. All right? I want to see you successful, but it takes a lot of hard work to earn an A, even a B. All right? This is not easy, because it combines, all the work that we've done for the 6 weeks of school, first 6 weeks of school, covering 12 lessons and a lot of arithmetic. So here we go. We're going to start off with conversions. All right, so I'm going to just make up some problems here. Let's say we have 8 years. And let's say we want to figure out how many seconds that is. How many seconds are in 8 years? And obviously that's a lot of time, right? So the answer is going to be big. All right, now when you do this on a test, free response, you have to show conversions. You have to show conversion factors. So write this down left. Okay, you can't just multiply, divide, and get an answer. Okay, you have to show conversion factors to let me know that you actually know what you're doing here. Now, if you don't know what that means, well then watch. Okay, so the first thing I'm going to do is I'm going to take 8 years. Okay, so divide your paper in two, draw that vertical line, go into Cornell style 2-column format. Okay, the problem goes on the left. All right, the process goes on the right. Okay, so speaking of process, so here we go. We're going to go from years to days first. In fact, let me tell you the concept first. So conceptually, it's going to go like this. We start off with years, and we get to get the seconds. So we're going to change years to days, not months. Because if you do that, you're going to have a problem, because when you change from months to days, you don't know whether to use 28 days in a month, 30 days in a month, or 31. So you're going to have to go years straight to days. All right, everybody should know there's 365 days a year. And then days to hours, because everyone knows there's 24 hours in a day. And then hours to minutes, all right, and then minutes to seconds. That's conceptually what you got to do. So you're going to start off with 8 years, and you're going to multiply it by, let me see, 1, 2, 3, 4 conversion factors. I know there's 365 days per year. Notice that the units cancel properly, and I end up with days. So 8 times 365 will give me how many days are in 8 years. Next, I got to multiply it by how many hours there are in a day. And there's 24 hours per one day. And notice that the days cancel. So what you do is you cancel out the units as you go, so you know that you're doing it correctly here. If the units don't cancel, well, then you're not doing it right. And the ratio or the fraction here is upside, it's backwards basically. That's how you know you're doing it correctly or not. I mean, I can't say it any other way than that. Now I got to change hours to minutes, and I know that there's 60 minutes per hour. And once again, cancel out the units. The hours divided by hours cancels out to 1. And now I'm in minutes. So if I want to know how many minutes there are in 8 years, all I do is multiply 8 times 365 times 24 times 60, which is obviously a big number. That's why I'm going to use, or let you guys use a calculator on the test, okay, for the conversion problems. Okay, and now you got to go from minutes to seconds, and you should know that there's 60 seconds per minute. And then cancel out the units properly. And then here we go. It's a big number, right? And notice the ending units here. We're in seconds. So it's going to give me some number of seconds, which is a huge number. So here we go. We're going to enter in 8, all right, times 365. Check your calculator here. Times 24 times 60 times 60. Double check it. 8 times 365 times 24 times 60 times 60. It is so easy to make a mistake, so you better check your work. And there's a lot of digits here, so 252288. Okay, so 2522252288. All right, let me check the calculator again with 3 zeros, and then I'm going to put some commas in. Every 3 digits you put commas in. That's 252,288,000 seconds. All right, in 8 years. That's a lot. All right, and expect a big answer. So that's basically how you convert time. All right, you're going to use your basic units of time. Let's work with distance now. So I'll cover a few different key things that you're going to have to be able to show me how to do. And again, when I say show conversion factors, I'm talking about these. These are called conversion factors. Each one of these fractions is called a conversion factor, and you have to show me this and also show how units cancel. Okay, on the test, if I don't see this, you're not going to get full credit, because you have to know how to work with this. When you guys get older and you get into your sophomore, junior, senior year, and you take classes like chemistry, biology, especially physics. All right, physics and chemistry, these two especially, not too much biology, but maybe. You're going to use this dimensional analysis, or what's called unit conversion. All right, so it will benefit you later on. You just got to trust me with that, because there's so much stuff that you guys don't know that you don't know. Okay, that you've got a lot to learn. Okay, and so all this stuff can prepare you for more classes later on, and you got to just trust us instructors to help you out. All right, because we know what's best for you. All right, so that's dealing with time. Let's switch to distance. Let's convert miles to, I don't know, how about centimeters? Centimeters is about the width of your finger. So let's convert 5 miles, all right, to some number of centimeters, which is a small unit of measurement. It's about this long. This is 1 centimeter. It's about the width of your finger. So how many of those are in 5 miles? And as you can imagine, just use your creativity here. It's a lot. Okay, so looking up at your uh, conversion table up here, all right, I can convert miles to feet by using this conversion factor here. So we're going to go from miles to feet. I can also go from feet to inches. Excuse me, and I have to figure out how many inches are in a, or how many centimeters are in a foot. Excuse me, how many centimeters are in an inch. So do I have it up here? Let's see here. Aha, here we go right here. All right, so I need this one and this one. All right, so and then so inches to centimeters. So there's my thought process. So here I go. So we're going to start off with 5 miles. I know that there's 5,280 feet per 1 mile. Okay, so now I cancel the units. Again, you got to show conversion factors and you got to show how to units cancel. All right, this is a technique used in many different mathematical courses and also sciences. Engineering, physics, chemistry. A lot of science courses use this technique, okay, all the time. From feet to inches, I know that there's 12 inches per foot. I also know that there's 2.54 centimeters per inch. So 2.54 centimeters per inch. So here we go. You just multiply 5 times 5280 times 12 times 2.54. All right, so clear it. And here we go. Enter in 5 times. Go slow and check your calculator as you go because it's so easy to make a mistake on it. I do it all the time. And that's why I always check my work. All right, so 5 times 5,280 times 12 times 12 times 2.54. Good. And you press the go button. All right, and that, my friends, is 804,672 centimeters. So notice that I end up with centimeters here. So here we go. Let me look at that number again. So 804,672. Come on. 672 centimeters. And put the comma in so you can read it better. So I did one with time. I did one with distance. Now let's do one that's also fractional. Okay, now I like this one. Here's a cool example here. I love this example because you can relate to it. You know, if you're cruising down the freeway at 80 miles per hour, how many feet per second is that? So 80 miles per hour is how many, all right, feet per second? How fast do you, how many feet do you travel every second? That's what I'm asking here. And if you're traveling down the freeway in a car at 80 miles per hour, there's a lot of feet per second you're traveling, guarantee it. So let me rewrite the fraction here. So any 80 miles per 1 hour, write it like this. Make it look like a fraction here. Okay, now notice I have distance and I have time. And in order to change it to feet per second, I got to change miles to feet and then seconds to hours. Excuse me, hours to seconds. Okay, so let's work with distance first. I know there's 5,000, all right, 280 feet per 1 mile. Now, if I do that first, notice that I have feet per hour here. I have feet up top, hours down below. I don't want feet per hour, I want feet per second. So I got to change to time now. I'm going to change hours to seconds, and that will take a couple conversion factors. unless you know how many seconds per hour, which I do. There's 3,600 seconds per hour. But if you don't know that, you do know that there's, for every 1 hour, all right, there's 60 seconds. Excuse me, 60 minutes. And notice when you do this, the hours cancel, and now I have feet per minute. But I don't want feet per minute, I want feet per second. So now I got to change from minutes to seconds. And I know that for every 1 minute, notice how I put minutes up top because I got to cancel the minutes out. And if they're down below, then you got to put them up top for them to cancel. Okay, so for every 1 minute, there's 60 seconds. So notice when you do this, the minutes cancel. So what do you get? So what I need to do is take 80 times 5,280 divided by 60 divided by 60, and I end up with these units. I end up with feet per second because those are the ending units. Feet per second. What do I get? So let's clear the calculator and this will start over. So 80, all right, times 5,280. Check your input here, okay, because you got to input it right. Divided by 60. Now it's down below, so every time you see a number in the denominator, you divide, because that fraction line means divide, right? So you divide by 60 twice. So divide by 60 again, and then you get 117.3 bar. So 117.3 bar, because it repeats, feet per second. So that means if you're going down the freeway at 80 miles per hour, every second you're traveling about 120 feet down the freeway. And that is a long way. And that's why when you go to driving school, they say they want a 3-second rule between you and the car, or they want to let you should have like 300 feet between you and the next car, because people typically travel on the freeway 60, 80 miles per hour. Nowadays, it's more like 80, especially in the 15 freeway. And if someone in front of you hits the brakes, okay, and they come to a complete stop real quick, you better have some major room between you guys, because if they slam on the brakes and you're going 80 miles an hour, well, you're traveling about 117 feet every second. And remember, it takes time to hit the brakes because it's called reaction time, and it takes time to hit the brakes and for you to slow down. And you're going to need a lot more room than you think. So keep that in mind when you go to driving school. Okay, and there's a lot more. So I got to cover a wide variety of things, so that's enough for that one. Let's switch to a different concept here. So number 4, I'm going to switch to equation solving. So write down solve for x. Let's make up an equation here. So 4x plus 3 times the quantity 2x minus 1 is equal to, I don't know, 20x plus 5. All right. Now let's write it over here. Let's solve it over here. So we got 4x plus 3 times the quantity 2x minus 1 is equal to 20x plus 5. Now the whole goal is to solve for x. So let's separate the two sides of the equation here, and let's remember, whatever you do to one side, you do the other side. So let's kick in a little distributive property first here, because I have to figure out what this is here. And if you're watching this video, okay, hopefully you have a red pen, all right, and annotate well. I'll be looking for that in when you show me this if you're doing the extra credit, okay? So we got 4x here, plus 3 times 2x is 6x, minus 3 times 1. So don't put a minus 1 there. You got to multiply twice here. Distribute means multiply. So 3 times 1 is 3 equals 20x plus 5. Now you got to combine the like terms. So 10x minus 3 equals 20x plus 5. 4x plus 6x is 10x. And I got to solve for x. So different ways you can do this. You can get your x's on the left by subtracting 20x, or you can subtract 10x and get your x's on the right. It doesn't matter. If you want to get them on the right, it looks like this. Okay, you got to add the opposite. Opposites cancel to 0 here. bring down the -3. Be careful right there. It's -3 because it's being subtracted. 20x minus 10x is 10x. I have to solve for my unknown. So I get 10x is equal to -8. A negative plus a negative is a bigger negative. And it's 10 times x here, so I have to divide by 10. And I get x is equal to -4/5. Okay, you have to simplify or reduce. All right, that's a negative fraction. All right, of course, and you're going to have to do something like this on the test here. So remember, again, we're going to distribute first. Distributive property, that's step 1. We're going to combine like terms. Combine like terms here. That's step 2. Right here, we're going to step 3 right here. This is the addition property of equality. Why? Because, subtraction property of equality here. Because we're subtracting 10 on both sides. I'm talking about 10x on both sides because right there. Subtraction property of equality. We do it again right here. So step 4, subtraction property of equality again. And then here, well, we're dividing both sides by something, right? So the division property of equality. All right, so you're going to have to justify in the test on the free response portion. Okay, so justify your work using the properties. So we're doing the algebra here, of course, but we're also justifying as we go. Okay, so we first distribute, then we combine like terms. You subtract 10x on both sides, balanced. Okay, so one's on the left, one's on the right. Here, notice that we subtracted 5 on both sides, so we use subtraction property again. And then here we divide both sides by 10, so I use division property of equality. And then, of course, we simplify your fraction. All right. So yeah, there's going to be a lot of this. This is a lot of Algebra 1 here. You got to be good at solving equations. Good at working with numbers here. Okay, number 5. Let's talk about inequalities, okay? So write down solve each, or solve, we'll just say solve the inequality. Oh, actually, you know what? I want to say solve and graph, because you're going to do a lot of graphing here. They're called inequalities, because you're not going to see an equal sign. You're going to see either a less than or greater than. Okay, so let's make one up. So we're going to do a few here. So 4x minus 1⅓ is equal to 5. So 4x minus 1⅓ equals 5. All right, so here we go. All right, and of course I want you guys to do some side work here. So here we go. Draw that line. Do the work on the left. Do the steps on the left and the work on the right. All right, so we want to always add the opposite first. So I see 4x minus 1⅓, so I'm going to add the opposite. All right, so I'll show you that in red. Oh, you know what? I'm sorry. Let me change the equation here. I want to illustrate a point. So let's change. I want to change the equation. I'm going to put a plus here. Okay, there's a reason for that. So just change your equation here before we begin. Okay, so it's 4x plus now, 1⅓ minus equals 5. So you want to add the opposite first. So you want to add -1⅓ to both sides. Or you can say subtract 1⅓ on both sides, same thing. Remember to stay balanced. So here's the left and right sides. Just draw a line right through the equal sign. Okay, now opposites cancel to 0. So you're going to get 4x on the left. But what do you get on the right? Well, let's go to the side, right? Let's do some side work. So you got to take 5 minus 1 1/3. To do that, you got to take 5 minus 1 minus 1/3 and think pizza, 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 pizza. All right, so here we go. Left to right. 5 minus 1 is 4. Now, think pizza. If you have 4 pizzas and for one of them, you eat 1 slice out of 3, you don't have 4 pizzas anymore. Okay, you got 3 in something, so you got a 3 in some fraction. So if you take away 1 slice from 3, then 2 slices out of 3 remain. Okay? All right, so think pizza. Put a smiley face there. I love pizza. Okay, now here's the deal. On this here, I know it's 4 times x, so you could do this, divide both sides by 4, but this is complicated for people. So don't do that. All right? Don't do that. Multiply by the reciprocal instead. All right, multiply by the reciprocal. So let's write that down. This is easier. Multiply by the reciprocal. If you're doing this extra credit video, then do a good job, okay? And take notes on the important points and write the key ideas down. All right, reciprocals multiply to 1. So put a 1 there. 1/4 of 4 is 1. All right, or you can think 4 divided by 4 is 1. When you multiply reciprocals, you always get 1. So this gives x here equal to this. And you got to change this to improper, unless you're really good at arithmetic. All right, so you go 3 times 3, so you multiply here, and then you add up top. So 3 times 3 is 9, plus 2 is 11. So you get 11/3. Notice the same denominator, times 1/4. And when you multiply fractions, you multiply up top first, and you get 11, and then you multiply down below second. All right, and you get 11/12. And there you go. Oops. I'm supposed to make an inequality here. Okay, so solve and graph. Shoot, I messed up here. So let's make this less than or equal to. All right, less than or equal to here, less than or equal to here, less than or equal to here, and less than or equal to here. Okay, so I apologize for that little spoof there. I wanted an inequality here, so make sure that everything is less than or equal to, because now I have to graph. Okay, so set up a number line. All right, here's 0, over here is 1. And 11/12 is really close to 1. It's right there, so 11/12. 12/12 is 1, so 11/12. If it was possible for me to divide this thing up in 12 equal parts, and I could show that, then I would, divide it all up in 11 parts and go over 11/12. So we're going to go closed here, and we're going to go, let me go red here first. We're going to close the 11/12, and less than or equal to is to the left. All right, all the numbers smaller than or less than or equal to 11/12 is to the left. So make sure you go closed. Okay. Okay. Now let's try another one. Okay, number 6. All right. Come on, computer, catch up with me here. Bear with me, guys. I'm having a little computer malfunction. Okay, here we go. Let's try it again. Okay, we're going to solve and graph another inequality, but this time we're going to have, let's say, negative 3 times 4x minus 2 is, let's see here. I just want to make something different here. Is less than, let's go 8 here. Okay, all right, here we go. Let's get started. Let's distribute first. These most people would distribute. That's the most common response I see on these right here. So there's different ways you can do it, but that's probably the easiest way you can do it. When you do that, you get negative 3 times 4x is negative 12x. Negative 3 times negative 2 is positive 6. Be careful. A negative times a negative is a positive. All right, and that's less than 8. All right. Oh, I'm supposed to be over here. Sorry, guys. Negative 3 times 4x minus 2 is less than 8. So distributing here, you get negative 12x. Distributing it twice, you get plus 6 is less than 8. Okay, all our work's supposed to be on the right. Let's add the opposite here first, and you get negative 12x is less than 2. And then we're going to divide by negative 12, and be careful right here. When you divide by a negative number, you got to switch the inequality. Switch the inequality, that's what they're called. All right, when dividing by a negative. Not a positive, but by a negative. All right, key concept. So the answer, all right, is not x less than negative 1/6. It's x greater than negative 1/6. You got to reduce and simplify. Reduce, or you can call it simplify, whatever you guys like to say. All right, 2/12 is 1/6, but remember it's negative, right? All right, let me highlight something here. So you switch from less than to greater than. You got to switch the inequality when you're dividing by a negative. That is the most common mistake I see, and I see it all day long. So pay attention to that and don't make the mistake, okay? Pay attention to details. All right, so if this is 0, and let me see if this is negative 1 here, this is negative 2, let's say. All right, and you divide it into 6 equal parts. So that's 2 equal parts, 4 equal parts. Better not do that. Let's do, I need 6 equal parts. So I got to divide this into 3 equal parts and this into 3 equal parts. Now I have 6 equal parts. And right here, that's negative 1/6. So you want all numbers greater than negative 1/6. So that's open, because negative 1/6 is not a solution. So make that open and to the right. Okay, open at 1/6 to the right. Why? Why to the right? Well, it's greater than, right? Greater than is always to the right. Greater than or bigger than, either one. Not only that, look at the direction that it points to. It's pretty darn obvious. Greater than. The reason why mathematicians use this symbol for greater than is because numbers get bigger to the right. I mean, look at the number line. 1, 2, 3, 4, 5. Greater than is always to the right. And that's why the symbol points to the right. It wouldn't make sense if it pointed the other direction. Okay? So think logically, think simply here. And remember my key points here. Because I guarantee you, that is the most common mistake any teacher sees, is that right there. So you got to pay attention to detail. When you multiply or divide by a negative, you always switch the inequality. All right, now let's get to compound inequalities here. Number 7. Compound means more than one. All right, so let's make one up. So negative 8 is less than x divided by 3 minus 1, which is less than or equal to, let's say, 5, let's say. Okay? And you know what? Let me change the negative 8. Let me make this negative 10 instead. Just to make things... Actually, that wouldn't have mattered. So, no, I want to change it to negative 4. Okay. That'll make it a little easier to graph. Okay, so let's bring it over here. So negative 4 is less than x divided by 3 minus 1 less than or equal to 5. Now, compound inequalities can be done 2 different ways. The fastest way is to consider that this compound inequality has a left part, a middle part, and a right part. Okay? Now you can separate this into an and statement, and some of you guys like to do that, which is fine. Okay, you can do that. So remember, this can be done in two different ways. You can separate it into this inequality and then this inequality, because negative 4 is less than x divided by 3 minus 1, and, all right, x divided by 3 minus 1 is less than or equal to 5. So you can solve it this way too. All right, and you'll get the same result. However, I think it's faster this way. So I like being, taking less time on doing things. So here we go. We're going to add the opposite here first. All right, negative 4 plus 1 is negative 3, which is less than. These cancel to 0. And you get x divided by 3 is less than or equal to 6. Now, I am not done solving for x. We got to isolate it in the middle, so I got to times by 3 on everything. Okay, negative 3 times 3 is negative 9, and that's less than x, less than or equal to 18. Okay, so if this is 0, negative 9 is over here somewhere, and negative 18 is twice the distance over here, and this means all numbers between negative 9 and 18, including 18. So it's open here, it's closed here. And x is any number between, all right, negative 9 and 18, because that's what this inequality means, all right, including the 18 because it's closed here. Open at the negative 9. It doesn't include there. So it's including the 18. So this is your key idea. And if you understand that graphing, it is easy because you're going to plot open here, closed here, and it's going to be all the numbers in between here. So x is any number through here. This is called the solution set. Okay, or you can do it right on the number line. Okay, so the key word is between. All numbers between negative 9 and 18, including the 18 because it could be equal to. There's an equal to portion here, but not negative 9. Negative 9 is not a solution. Not a solution here. Okay, and you're going to have one of these on the test too. And so you can solve it using two inequalities or you can solve it using one. Okay, it's totally up to you. All right, another inequality that you're going to see on the test is, let me see, this number 8 is the OR statement. Okay, so here we go. You got negative, let's say negative 4 is less than, no, so negative 4x is less than, I'm sorry. Minus 1 is less than 5, or something like that. Or let's say 3x plus 2 is less than 5. Let me see. Let me visualize this to make sure this is going to be a good one. So 6. Okay, so 1.5. Let me make this, actually, let's make this greater than. I'm just thinking, let me pause the video. I just got to double check something here. Okay, I'm good now. Okay, so let's double check things here. So I want you guys to make sure you wrote this down correctly here. Negative 4x minus 1 is greater than 5, or, okay, this is an or statement now. 3x plus 2 is less than or equal to 5. So change that to less than or equal to. And let's get started. Okay, so I'm going to bring it over here. So negative 4x minus 1 is greater than 5. Let's work on that first. So we're going to add the opposite for here first. And remember, split the inequality up into two parts, right? So we're going to add the opposite here first. And we get negative 4x greater than 6. Divide by negative 4. Be careful here. You're going to get x is less than. Okay, switch the inequality from greater than to less than because you divide by negative. 6 fourths, let me see, 6 fourths divides once, remainder 2. So 1.5, so negative 1.5 here. Second equation is 3x plus 2 is less than or equal to 5. So negative, subtract 2, you get 3x is less than or equal to 3. Divide by 3. And in this case, I'm sorry. We're going to have to change something here. I want to change this. I have to change this inequality. So make the change here. There's a reason for that. Just go with the flow here, guys. I want to make sure that things end up kind of nicely here. So change your inequality. Sorry about that. I just had to change the problem. So pause the video and make your changes. Okay. So what you get is x greater than or equal to 1. All right. Now let's graph. Here's 0. 1's right here. Negative 1 is here. Negative 2 is here. Negative 1.5 is between negative 1 and negative 2. So here it's going to be open, and it's going to be all numbers less than or equal to 1.5. That lies to the left. Here it's going to be closed. All right, all numbers including 1 and to the right. And so x could be here or x could be here because this is an or statement. All right, not an and statement. So x can be in either position, but not both. Okay, so you're going to have one of these bad boys on the test too. All right. Now let's see what we've done so far. Let's go back to the beginning. We did some conversions on time. We did a conversion with distance. We did a conversion with speed, okay, which is a rate. We solved an equation. We also justify the steps, and justifying will be on the test as well. We solved an inequality here, a single inequality. We solved, well, two different inequalities, one with less than or equal to symbol. We also solved one with a less than symbol, but also remembering the key idea that whenever you divide by a negative number, you switch the inequality. I included that because that will be on the test too. We talked about a compound inequality here with an and statement. And we also talked about an inequality with compound inequality with an or statement. Okay, now let's talk about literal equations. Number 9. This is section 1.6 in your notes, just so you know. So if you want to open up your notes to literal equations, that would be good. All right, so let's get some experience, and I'm going to do a few. So let me just take some equations here. So a is equal to 1/2 base times height. You see this in grade school. This is the area of a triangle. And let's say we solve, all right, for h. All right, so let's bring it over here. A equals 1/2 base times height. And let's put the multiplication symbols in because these are all being multiplied. Okay, and we want to solve for h in this case, which is right here. Now you can do this in one step or two. I've seen when I watched you guys like stepping things out one step at a time. So I'm going to do one step at a time. That might make more sense to you guys. So just trying to help you out as much as I can. So I'm going to divide the equation into two parts. Okay, left and a right. Okay, I gotta multiply by the reciprocal here to clear the fraction. So multiply by the reciprocal, which is 2. So times 2 times 2. Whenever you multiply the reciprocals, they cancel to 1. 2 times 1/2 is 1. So I get 2 times a is equal to b times h. You multiply by the reciprocal. Now it's b times h. And the inverse of multiplying is dividing. So I'm going to divide by b because I want to cancel out the b. b divided by b is 1. So I get 2 times a divided by b is equal to h. All right? And notice that I solve for h. The similar process would hold for b. If you solve for b, it'd be almost the same thing, but the b and the h would be switched. Okay? That's one possible equation. Let's take a look at another one. So let's suppose that you have P is equal to 2 times L plus 2 times W. This you've seen too because this is the perimeter of a rectangle. Every rectangle here has 2 widths and 2 lengths. And the perimeter is the distance around, so you add 2 L's plus 2 W's. All right, and let's suppose that we want to solve for L, okay? So let's take it off to the right side and let's work on it. All right, so here we go. So you're solving for L, and L is right here. Okay, it's being multiplied by 2, and you're adding 2W to it. So let's add the opposite first. Opposites always cancel to 0. 2W minus 2W is 0. Let's split the sides here. So you've got 2L on the right is equal to P minus 2W, and they're not like terms. So you cannot combine them. Okay, unlike terms. Cannot combine. Okay, now you're not done solving for L, so you can do one of two things. You can divide both sides by 2, or you can multiply by the reciprocal. So if you divide by 2, it looks like this. So one way a solution could look is this. P minus 2W, all divided by 2, is equal to L. Now, if you didn't want to do it that way, you can do it this way. So I'm going to solve it 2 different ways so you can see it. If you multiply by the reciprocal, it looks like this. Reciprocal of 2 is 1/2, and notice the 2's cancel. Now, if you multiply the left side by the reciprocal, you got to put parentheses around it. So it looks like this. 1/2 times a quantity, P minus 2W, is equal to L. And you got to wonder, are these the same? And the answer is yes, because if you distribute through, okay, you get 1/2 times P, which is right here, P halves, and then 1/2 times 2W, well, that's W, and that's this right here. 2W divided by 2 is W. So these are the same, okay? They just look different, but they're the same. They look different, but they're the same. So that's why when you were checking my answers with your work here, when you guys were working on this in the beginning in section 1.6, this is section 1.6 in your notes. When you're looking at your homework, you might have done it correctly, but it may look different from my answer. Why? Because there's 2 different ways to write the answer. So you have to analyze them carefully and know that they are the same or different. Okay, let's work on another one. Let's use the, let's go back to the famous Einstein equation, and let's solve for C. Okay, so take A equals M times C squared. Notice how I wrote it. It's M times C squared. And let's solve for C, which happens to be squared. So we're going to have to do 2 steps here. So the inverse of multiplying by M is dividing by M, step 1. So you get E divided by M is equal to C squared. 1 times C squared is C squared. And the inverse of squaring is square rooting. And you always do the inverse in mathematics. It's called the square root. Okay, so what you have to do is this. Square root the left side, square root the right side. These cancel. And C is equal to the square root of E divided by M. And notice that I didn't write it like this. Okay, this is incorrect. Okay, that's incorrect. You got to square root the entire fraction. All right, so make sure that square root symbol covers the entire fraction. Okay, another one that we dealt with was this one here, the famous kinetic energy equation. That's equal to 1/2 times mass times velocity squared. So let's say that we want to solve for v, all right, which is being squared at this moment. It's similar to what we just did, but because of the fraction, the 1/2, it takes another step. So let's write it like this: 1/2 times m times v squared. Okay, now the first thing we do, everything's being multiplied here, so we're going to have to multiply by the reciprocal first. Okay, so we're going to have to multiply both sides by 2 here and here. And the reciprocals cancel to 1. So you get 2k on the left. Notice this is the left side. Equals, the fractions cancel. 2 times 1/2 is 1, is equal to m times v squared. Okay, do the inverse of multiplying, which is dividing. So divide by m. M divided by m is 1. So you get 2 times k divided by m is equal to v squared. And as I said back here, the inverse of squaring is called square rooting. Anytime you see a square, you square root both sides. Here and here. And the square cancels out the root. The root cancels out the square, giving you v. And you get the square root of 2 times k divided by m. Okay, and there's, there's thousands of different equations that we could work with. All right, we probably solved maybe 15 different ones during the lesson when we worked on it. So go to section 1.6 and review and practice, because trust me, it'll be beneficial and you'll need it. Okay, so let me see. We did inequalities, equations, little equations. We did conversions. Let me see what else. Oh, absolute value. So okay, so let's do. Let me see here. This is number 9. Let's go to number 10. Here we go. Last one. So number 10, absolute value equations. Absolute value equations. Okay, something like this. The absolute value of 5x minus 1 is equal to, actually, before I do that, let's do something simple. So the absolute value of x is equal to 8. Okay, what numbers are exactly 8 units away from 0? All right, the absolute value of what numbers give you 8? All right, and here, x can be either 8 or negative 8. Oops, negative 8. I got to rewrite that. Okay, negative 8. Or you can write it like plus or minus 8. Why? Well, the absolute value of 8 equals 8, and the absolute value of negative 8 equals 8, because distance is always positive. As I was saying back in the lesson, distance is always positive. Highlight that. Okay? So that's the y part. Okay, why are there 2 answers? Well, if you take your answers and substitute them back in, all right, sub to check, you can check your work. All right, and this is my check right here. That is the check. Check results. If I can spell that. Okay, so you get 2 results here. Let's do another one. So the absolute value of x is equal to, let's say, 12. Well, what 2 numbers, when you take the absolute value, and give you 12? Well, the absolute value of 12 is 12. The absolute value of negative 12 is 12. So plus or minus 12. How about this one? How about the absolute value of x is equal to negative 3? Try that. Pause the video. Give it a shot. Okay, now let's check your work. Okay, it cannot be 3 or negative 3. All right, the absolute value of 3 is positive 3, so 3 is not a solution. The absolute value of negative 3 is 3, so negative 3 is not a solution. So negative 3 and 3 are not solutions. All right, this is negative, all right, and this is positive, and so there's no solution here because the absolute value can never be negative. Absolute value of a number, all right, can never be negative because distance is always positive. Never, okay? So no solution here. All right, now let's get on to bigger and better things. Okay, so let's say we have the absolute value of 5x minus 7 is equal to 8. All right. Now, remember what I was saying earlier in the lesson. This is lesson 10 or section 110. So if you want to get out section 1-10, go for it. Okay, look at it. We're going to transform it into two equations. Transform into two equations. All right, without absolute value. Why do I say that? Well, okay, whatever this is, okay, this 5x minus 7, whatever it is, it could be equal to 8 because the absolute value of 8 is 8. Or it can be equal to negative 8 because I know that the absolute value of negative 8 is equal to 8 too. So this quantity on the inside here, it could be equal to 8 or negative 8. So when you write your two equations, you write them without absolute value. 5x minus 7 could be equal to 8, or 5x minus 7 could be equal to negative 8, because the absolute value of either one of those numbers is 8. And now you solve for those unknowns. So add 7, and you get 5x equals 15. 5 times 3 is 15, so x is 3. Or here, if you add 7, you get 5x is equal to negative 8 plus 7 is negative 1. And if you divide by 5, you get x is equal to negative 1/5. Yes, they can be fractions. Okay? So what you want to do is transform it into two equations without absolute value. W/O is without. Notice there's no absolute value here. If I see that, I'll mark it wrong. Okay? Why? Because you're not thinking about it correctly. The inside quantity, whatever it may be, can either be 8 or negative 8. So you write it without absolute value so you can solve them separately. All right, now I want you guys to try one. So absolute value of 8x plus 4 is equal to, let's say, 12. All right, pause the video, all right, and play when you're ready. All right, go for it. Okay, now I'm assuming that you've already tried it, and now you're checking. Okay, so I know that whatever this is inside here, okay, it could be equal to either 12 or negative 12. Why? Because the absolute value of 12 is 12. The absolute value of negative 12 is 12. That's why we can transform it. So 8x plus 4 could be equal to 12, or 8x plus 4 could be equal to negative 12. Here we go. Let's add the opposite first. You get 8x is equal to 8, so x can be 1. If you substitute 1 in here, you get 8 times 1 is 8, plus 4 is 12. Absolute value is 12 is 12, so this one checks out. If you subtract 4 here, you get 8x is equal to negative 16, and you divide by 8, you get x is negative 2. So let's check that. If you put a negative 2 here, 8 times negative 2 is negative 16. Negative 16 plus 4 equals negative 12. And the absolute value of negative 12 is 12, which checks out. So there's my check on the second solution. So what you want to do when you get your results, you take this and you substitute it back into the original equation. So substitute to check. Okay? I always do that because, if you're on a test, I'm not going to tell you whether you did it right or not, but you can tell by taking your answers and substituting back in the original equation. You can check both of these. There's two solutions here. 8 times 1 is 8 plus 4 is 12. And absolute value of 12 is 12. Or the next one, I already did it. You can check it there too. So always check your solutions in the equation. And that will tell you whether you're not right or not. Okay, that is a lot. And I'm going to stop here. There's a lot of work here. You can watch it as many times as you want. I went through a lot of variations here. For another review here, make sure you show me you're working your spiral on this. And if you do, and you have this whole thing done, I will give you a huge 12-point extra credit points in your homework category, to reward you for your hard work and your effort. Okay, this is Mr. Ainsworth. I'll see you on test day. Bye-bye.